So we've moved to our last set of identities for the semester, and today we're going to talk about half-angle identities. Now, half-angle identities are exactly what they say they are. We're going to try to find exact values for something like the cosine of 22.5, which just happens to be half of 45. All right, or we can find the exact value of cosine of pi over 12, which is half of pi over 6. All right, so that's going to be the goal. Now, actually coming up with the proof of the verification is a little difficult, so follow along closely. You don't necessarily have to know how the proof happens, but let's just go through it. We're going to first take and use the cosine of 2x as our base. All right, and we know we have an identity of the cosine of 2x being 2 cosine squared minus 1. I'm going to do a little algebra, bring 1 to the other side in this step here. Divide by 2 to both sides here. Square root both sides here. Now, here's the magic. If we decide to let 2x equal delta, then we can say by dividing that x is equal to delta over 2. So now let's make some substitutions. I know that 2x equals delta, so I've made that substitution right here. And x is equal to delta over 2. So what we've come up with is we've come up with this identity here that says basically the cosine of delta over 2, or the half-angle identity for the cosine, is equal to plus or minus the square root of the cosine of delta, which is x, or it's just any variable, plus 1 over 2. So this here is the cosine of the half-angle identity. Plus and minus is going to refer to what quadrant you're in. Let's look at the next one. Again, we're going to start with the cosine of 2x identity, but this time we're going to use the sine identity, and we're going to do that same algebra. I'm going to bring 1 over. I'm going to divide by -2, so notice the signs switch since I'm dividing by a negative. Take the square root of both sides. Again, make the substitution of delta equals 2x, so therefore x is equal to delta over 2. Make those substitutions, and notice what I have here, and I've screwed up. We're going to have to take and rewrite these because I didn't notice that. But this is actually the sine of x, and this is the sine of x over 2. So again, here's your identity. Moving on, tangent of a half angle is equal to the sine of the half angle over the cosine of the half angle. And we know that the sine of the half angle is equal to 1 minus the cosine of delta over 2, all rooted, and 1 plus the cosine of delta all over 2, square rooted. Multiplying by the reciprocal, we end up with 1 minus cosine over 1 plus cosine, and that's our half angle for tangent identity. Now we're going to use some of these. We're going to find the exact value of cosine of pi over 8. Now we could take and bring this back into degrees, but no point because we know this is a half of something. So this is a cosine of half of pi over 4. I'll just put this in sets of parentheses. So our angle, delta, is equal to pi over 4 in this case. And since we're talking about the cosine identity, we know that the cosine identity half x is equal to square root of cosine of x plus 1 over 2. x in this case, or delta, doesn't matter, it's just a variable, is pi over 4. So I'm going to substitute back in. That's the cosine of pi over 4 plus 1 all over 2. Now simplifying these are going to be a little ugly. It involves algebra. We know pi over 8 is in the first quadrant, so this is going to be a positive answer since it's a cosine. All right. Again, simplifying these is not going to be necessarily easy because we get a lot of complex fractions and square roots. The cosine of pi over 4 is root 2 over 2. I'm adding 1 to that, but instead of saying 1, I'm going to say 2 over 2, and that's all over 2 in a radical. So notice I have a radical within a radical. Going to multiply by the reciprocal, so this gets me radical 2 plus 2, and if I multiply by the reciprocal of the denominator, I get 4, all square rooted. So you'll notice in the end that in the numerator, I have the radical of radical 2 plus 2, but in the denominator I have the square root of 4, which is actually 2. So that's going to be my final solution. We're going to take and use a half angle to find the exact value of the sine of 15. And so we know that 15 degrees is half of 30. So we really have the sine of a half of 30 degrees. So in this case, our angle value, delta, is equal to 30. Delta could just as easily be x. It really doesn't matter. All right. And we know our sine of x over 2 identity is equivalent to the square root of 1 minus cosine of x all over 2. X we said was 30 degrees, so we have 1 minus the cosine of 30 degrees all over 2. It's all radical. Simplifying, cosine of 30 degrees is 1 minus root 3 over 2 over 2. Again, I'm going to get a common denominator. So this is 2 minus root 3 over 2 all over 2, which reduces to 2 minus root 3 over 4 in a radical. It's a little messy, sorry. And we get 2 minus root 3 all within a radical over 2. Since we're in the first quadrant once again, we have a positive. Moving on to the next example. Now it looks like we've got a triangle problem. We're looking to find the sine of a over 2, where the cosine of a is equal to 1/5. Again, we just did a sine of half angle identity, which was equivalent to the square root of 1 minus cosine a over 2. And we just so happen to have the cosine of a right here. So this is just a plug and chug problem. We have 1 minus, instead of saying the cosine of a, we're going to say 1/5. So this wasn't even a triangle problem because we had everything we needed. 1 minus 1/5 is 4/5. All over 2 is the same thing as times a half. That's all radical. We get a reduction, so that's 2 over 5 all rooted, which is 2 root 5. I lied. Which is root 10 over 5. We're in the fourth quadrant, all right, and we're trying to find half of an angle in the fourth quadrant. So let's take a peek. Here's an angle in the fourth quadrant anywhere. So I'm basically between 270 and 360 degrees. And if I take half of either one of those, I get 180 and roughly, what, 135? So my half angle, half of A, is going to be somewhere in the second quadrant. The sign in the second quadrant is going to be positive. So there we have it. All right? Moving forward. An identity. All right, so I would say the tangent of x over 2 is the most complicated. So we know that's the sine of x over 2 or the cosine of x over 2, or as we stated earlier, 1 minus cosine of x over 1 plus cosine of x. And notice, coincidentally, that I have 1 minus cosine of x in my identity and the square root of 1 minus cosine of x. Well, I'd like to keep this on top. Now, the only way to do that without changing the value of this is to multiply by some form of 1. So what I'm going to do is I'm going to say, all right, well, if I multiply a radical by itself, then whatever that term is just pops out of the radical. So I'm actually going to multiply by this form of 1. In doing that, root of 1 minus cosine times root of 1 minus cosine is just 1 minus cosine. No root, which is exactly what I wanted. Now in the denominator, I'm going to FOIL this out. That's 1 minus cosine squared. It's a difference of squares. Now this is good because I know I have a Pythagorean identity here. So this is 1 minus cosine of x over the square root of sine squared of x. And I know the square root of sine squared is just sine. So I have 1 minus the cosine of x over the sine of x, which is exactly what I wanted to get. So there we go, verified. This one looks a lot more complicated because I have a tangent and a cotangent half angle identity, but luckily the right side's not very complicated. That's just 2 over sine. So that's what I'm going to go for. So in this case I have, for the tangent of x over 2, probably need a bigger root, I have 1 minus cosine of x over 1 plus cosine of x. Going to add that to the reciprocal of that, which is the radical of 1 plus cosine of x over 1 minus cosine of x. Now, I need to get rid of these radicals because, like I said, I'm trying to get 2 over the sine of x. In order to get rid of the radicals, how am I going to do that? Like I said before, I could multiply things by themselves. I tell you what, I'm going to take and rationalize by the conjugate, I guess. I will multiply this guy by root 1 minus, or sorry, 1 plus cosine of x over 1 plus cosine of x. This could take a while. I'm going to multiply this guy here by 1 minus cosine of x over root 1 minus cosine of x. In doing so, I get the root of 1 minus cosine squared of x over 1 plus cosine added to 1 minus cosine squared of x in the radical over 1 minus cosine of x. Both numerators actually get me sine squared of x. And my denominator is going to be different, so I'm going to do a couple of steps in one at this point. I'm going to take and multiply to get a common denominator of 1 minus cosine of x over 1 minus cosine of x here, and give this a 1 plus cosine of x over 1 plus cosine of x. So in our next step, we have in the denominator, I have 1 minus cosine squared of x, because that's 1 plus cosine times 1 minus cosine. In the numerator, this sine squared becomes a cosine, so I have 1 minus cosine of x times cosine of x. That's actually cosine squared, sorry. Oh no, I lied. That's sine of x plus sine of x times 1 plus cosine of x. I'll do a little distribution now, and I get sine of x minus sine of x cosine of x plus sine of x plus sine of x cosine of x all over. Rather than 1 minus cosine squared, I'm going to say sine squared. And you'll notice on top, sine x cosine x and negative sine x cosine x go. I'm left with 2 sine of x over sine squared of x, which was equal to 2 over sine of x, or 2 cosecant of x. And that was the goal I was trying to get to if you look back at the original problem. So there we go. And here are your questions for today. In the first one, you'll probably have to go to a triangle type problem. Second one's a verification, so you won't be able to put that on the answer form, so just do that and I'll have the solution up on the board.